Approximations and estimates. The mathematical sign indicates that the quantity on the left side of the symbol is approximately the same as the quantity on the right side of the symbol. This sign is used when we want to approximate quantities, whereby the quantity is a rough figure, but you want to approximate it to a quantity which is more exact, which is more rounded off, which is more or less a whole number, or a quantity that is realizable. So use this sign whenever you have such a situation. And approximations are very helpful when you want to approximate quantities. Say you want to have a rough estimation of a figure when you're calculating. Now, say we have a vendor. This vendor earns $52.55 each week. Then the annual salary will be $52.55 multiplied by 52 weeks, which make up a year. Now, estimates of the annual salary, rounding off to the nearest whole number. To the nearest whole number, the money earned per week will be $53, and the weeks will still remain $50. Therefore, you get $2,756. Rounding off to the nearest 10, $52 to the nearest 10 is $50, and 52 weeks to the nearest 10 is what? 50. 50 multiplied by 50 is 2,500. Then rounding off to the two significant figures, $52.55 becomes $53. We'll talk more about rounding off to significant figures and decimal point numbers later. Then it becomes 53 times 52 and you get 2,756. Then this is an approximation and estimation of the annual salary earned by this vendor. Rounding off. The numbers are rounded off to the nearest whole number, 10, 100, 1,000, 10,000, etc. 1, 2, 3, 4 are rounded down, and 5, 6, 7, 8, 9 are rounded up. Example, round off 829,435 to 2 decimal places, 1 decimal place, to the nearest whole number, to the nearest 10, to the nearest 100, to the nearest 1,000. To the 2 decimal places, we look at our number. Then we want to be left with 2 decimal places. So we go to the second decimal place, which is 3 in this case. Then look at the number on its right. We have 5. So 5 rounds up. If 5 rounds up, it becomes 10. We add a 1 on the second decimal place number, which is 3. Then we get 4. Therefore, it becomes 829,44 to 2 decimal places. Then we go to 1 decimal place. We look at the position, which is what? The 1 decimal place, which is 4 in this case. Therefore, after looking at 4, we look at what? At the right number, which is what? 3. And like we said above, 3 rounds down, then it becomes what? 0. Therefore, 4 remains like 4. We do not add anything to 4. Then to the nearest whole number. Again, we look at the first whole number, and we look at the decimal part. When we look at the decimal part, can the decimal part round up? You cannot, because there is 4. Therefore, it remains like that. We get 829 to the nearest 10. To the nearest 10, which value is the 10? The 2 here is the 10. Therefore, we look at what? At the number on the right. The number on the right is what? Is 9. 9 rounds up. Therefore, add 1 on 2, it becomes 3. Then we have 830. Then, rounding off to the nearest 100, we look at the what? At the number that is supposed to be in the hundreds column. That is 8 in this case. We look at the what? At the right number. 2. 2 rounds down, it becomes 0. You do not add anything you 8, then for it becomes 800. Then we look at what? Rounding to the nearest 1,000. We look at the column of 1,000. We have nothing, which means there's 0. Therefore, after looking at that 0, in this case you have to imagine there's a 0 for it to work. Therefore, you put an imaginary 0 if in your head. Then after putting that imaginary 0, you look at the number at the right. The number at the right will be what? Will be 8. 8 rounds up. Therefore, you add what? 1. Therefore, it becomes 1,000. Significant figures. Significant figure, what do you mean by significant? A significant figure is a number that makes sense in the context of the value of the number. Say you have a decimal place, you have a decimal point number. The zeros at the front are not significant because they don't give the actual value of a number. You may take them away and the value of the number may remain. Say if you were to transform that number into standard form, the zeros, you lose them, but the figures which are significant, you cannot lose them. If you lose them, then the number does not make sense. If they are there, they make the number make sense. What do you mean by this? If you have a number like 0.000023, 2 is the most significant figure. Why? Because it is the first value that gives the number significance. If you were to take away the first 0, this number would still make sense because it can be converted to other forms and it can make sense. But if you remove this 2, it no longer makes sense. It's no longer having this value. Then we go to the next number, 1512,234. 1 is the most significant figure, followed by 5, then 1, 2, 2, 3, and lastly 4. Rounding off 829,435 to 1 significant figure, 2 significant figure, 3 significant figure, 4 significant figure, 5 significant figure. Rounding off to the first significant figure. Our first significant figure in this number is what? Is 8. Then again, we look at the number on the right. The number on the right is what? Is 2. 2 rounds down. If 2 rounds down, then it means what? It becomes 0. You do not add anything to 8 and it becomes 800. We go to 2 significant figures. We look at what? At 2, since it's the second significant figure. We look at the what? At the right number, that is 9. 9 rounds up, therefore we add 1 on 2 and 9 becomes 0. We get 830. We now go to 3 significant figures. 3 significant figures. Our third significant figure is what? Is 9. We look at the number on the right. Number on the right is what? Is 4. 4 rounds down, therefore it becomes 829. 4 significant figures. 4 is the fourth significant figure. We look at the number on the right is 3. 3 rounds down, therefore we get 829,4. Fifth significant figure. 3 is the fifth significant figure. We look at the number on the right. The number on the right is what? Is 5. 5 rounds up, therefore 3 becomes 4. We're going to start with A. $31,095 to 2 decimal places. 9 here is the second decimal place, 0 is the first decimal place, so we focus on 9. Now we look on the right side, we have 5. 5 rounds up, therefore we get 10, then we add a 1 on 0, we get 31,10. Now part 2. 2 significant figures, 31,095 to 2 significant figures. 1 here is the second significant figure, 3 being the first. Therefore we focus on 0. 0 does not round up, therefore we have 31. 31 is our final answer. Now we want to express 7 over 30 as a recurring decimal. Now from our previous lecture on number concepts and operations, covered how to convert a fraction into a decimal point number, a decimal fraction. Therefore we have 7 over 30. Want to convert it into a decimal fraction. Like I said before, we carry out a long division or any other type of division. So 30 into 7, that's 0. We add a comma there, we add another 0. 30 into 70, that's 2. Remainder 10. We add another 0. 30 into 100, that's 3. And then we add another remainder 10. Then we add another 0, we get another 3. Then from this point onwards, you're going to discover that we are going to have a remainder of 10 and 3 as the quotient of the division. Therefore, the recursion pattern occurs, the recursion of 3. So our answer is 0.2333 ... These 3 dots represent that it's going on, it's recurring. Zero, comma, 2, 3, 3, 3, and you put that dot on there. It shows that the 3 is recurring. Now on to the last question. Start with A. 0,978. Sorry, 0,0978 to 2 decimal places. The second decimal place is what? Is 9. So we focus on 7. And 7 rounds up, so you get 9 becomes 10. We add the 1 to the first decimal place, which is 1. Then we get what? We get 0,1. And that will be our final answer, 0,1. Okay, the last part we are not going to cover it. We are going to cover it in our future lessons, standard form. We haven't learned about it yet. Now let's go on to B. 0,0978. Nine is the first significant figure, 7 being the second. So our focus is on what? Is on 7. Therefore 8 is what? Is what will determine how we round. 8 rounds up. So we have 0,098. That will be our final answer. 0,098. That is our final answer. Like I said before, we haven't covered standard form yet.